Hello, today I'll be solving 721 account merge. Let me share screen. All right, so we have a list of accounts. There's a list of strings where first element is a name, the rest of element is emails. We would like to merge this account. Two accounts definitely belong to the same person if common email is found. Notice that even two accounts have the same names, they belong to different people. Person can have n numbers of accounts officially, but all accounts definitely with the same name. After merging accounts, return the accounts as the following format. The first element of each account is the name, the rest of element are emails in sorted order. The account themselves can be written in any order. So we have to our goal is to merge accounts, right? So if we have account 0 and we can merge with account 1 because it has email into account 0, and we can merge into account 2, and then so we create this kind of structure that first that represent all this merging process, right? It even would be better to have a like account, yeah. And then what we're gonna do, we're gonna merge and return new set and copy into new set and return new set, new list, return new list of accounts. And if we take a look at step 1, building this structure, it looked like a tree, right? But it would be even better if we have like this. So like star structure, not like tree. Because when we start merging this into this, right, 1 into 2, and then we merge 2 into 1, but 1 merged into 0, so we have to merge 2 into 0 as well. And this is what union find with collapsing search give us. We can create this structure when it's like a star structure, when all several, this is like specific feature of union finds that we have union representative of the set. So this is perfect for us to solve this. This is why we'll be using union find. Yeah, and this is why union find is perfect, because it will help us create this star structure, and then when we will be merging, we will be merging all in one, which is good because in this case, if we merging 2 into 1, as first we merging 1 into 0, right? And return 0, and then merging 2 into 1, but we are not returning 1 because 1 is merged, and we had to instead merge into 0. So we're not going to have this problem. So in this case, it will be overall we will go through a couple we will have couple passes. First, we will create union, find, then um, we will merge, and then we will copy into new list, and then we return. So it's basically offense time and offense space complexity for the solution. So let's go and implement this. And first thing that we have to implement, we have to first let's calculate length of accounts. Let's rename it to capital A. And so first we will calculate length of account. Then we will create a parents array, which will be, I like to have -1 multiplied by L. Then we create two function union xy and find. This is standard thing for union find, right? So for union, what we're gonna do, we gonna find root for x. Then we gonna find root for y. And then we gonna assign parent of x root. Oh, we don't have to find the equals y root, right? We don't have to find y root, or no, we have to find. This is the whole thing with all pointed into one representative. And find will be, so we assign current to some value, and while current equal not equal -1, what we're gonna do, we're gonna current assign parent of current. Speaking in rhymes. Okay, so this is the whole union find thing. Now we have to create store for emails, and we will enumerate through index value in A. In all accounts, what we're gonna do, oh yeah, so this is n multiplied by m, I would say, because if we have this is amount of emails, this is amount of accounts. Yeah, but yeah, so this is how it will be. And what is complexity we have? Oh, we have in 1,000. It's kind of on edge, but we will see. It depends how many accounts we have and how many emails we have. So let's continue. For email in account, starting from 1, if store has email, right? Then we will store index into like this. Equal index or no. Okay, so the thing is we have to find index. And what we're gonna do, we're gonna assign we have it's for else, right? The union what we found, so it will be parent this with index. So we union nodes that we have with I would say, can I do find? It will be too much finds. Okay, let's try it this way. So first, after this, we're gonna have our entire union parents array populated properly. And then what we're gonna do, we're gonna iterate and we're gonna merge arrays. Right. So for every if find I not equal -1, meaning that this is definitely root. It's not connection, it's a root of the union. We may have a couple of them, right? Like in this case, in the second, we will have like 1, 2, 3, 4, 5 roots. So it's not like a tree, but it's like a forest, more like a forest thing. And so if we have, so we have find index, right? We found parent of our current. If this parent not equal -1, meaning that there is a real parent, we have to merge account I emails into account, let's call it A, into A found index emails. For that, what we're gonna do, we're gonna extend, right? So we're gonna extend. So we're gonna say AFI extend with AI but we don't have to include name, so it will be 1. Okay, so after merging, we have our step 2 here. We're gonna create result array, which is results, and we iterate again. And in this case, if we have -1, That means that we have a root, and all emails into this root will be merged to our root node like this, right? So we have to return only A0 because all other node dependent on that, our emails that what are into this node 2 will be merged to 0. So in this case, we will create new account and oops, sorry, and we're gonna add account append, I guess. Account 0, which is name, and then we have to return it into sorted order. So we will append whatever we have starting from 1. We will sort it and we will set it just in case, right? And we return res, and that will be it. Yeah, I'm not sure if I have to union with I, because it will be in union operations there is a find anyway, so it doesn't matter. And store, yeah, this is what we have. And here we find also we should update store too, right? So this is why I'm thinking we should do it in any case. If we are found or not found, we are updating store with find I every time. For this email. So when we, okay, yeah. Let's give it a try. Okay, we're returning nothing. Looking good, looking good. Okay, why we're returning nothing? Because, yeah, let's print. I probably made mistake somewhere in union find. So let's print P in store. This is what I see. Okay, still no. Okay, let's print. So after all union completed before merging, so this is merge, this is select, copy into new list step, and this is union find thing. And before this, let's print, no, after this, let's print index value, right? Let's print our union find array. Oh yeah, so yeah, I see the problem. Enumerate, obviously enumerate. If we have index value, we have to enumerate. Nope. Okay, union find. Result. Oh yes, obviously we have to add it here. Result append new account. However, I still don't understand why print is not working. Okay, looking good. Why print is not working? Yeah, I would do set from here, honestly, because emails could be repeated. So we union store. Index value. Oh, this is something wrong. It has to be like this, right? Yeah. And here is the same. And here is the same. But also question, do we have to? We enumerating accounts for email from account, every account to from one to the end. So we checking if the email is in store. And it doesn't matter. The only thing that we have to check if x are not equal y are, because in this case, if we have a cycle in here, right? Yeah, I think there is a problem with hidden, because this should be here, not on the function. Oh, this also should be here, right? No. Oh, return outside the function. Okay, wait. So this is a function. This is inside function. Let's do some formatting. This is inside function. This is inside function here. Now it's good. Okay. We got something, but we got it not good. So a union xy. Yeah, so this will be parent, probably one way. And there is a problem with the find here. Like this. And then here. Because we will be returning -1 all the time. And this is why we have -1. Now we got something much better. So here, yeah, it's not connected, which is fine. This one is connection. So 0 and 1 will be merged, which is good. So Fourier range find I not equal -1. So we merge. Then we append name. Then we append emails. And then we append new account. For I, we found and we extended. I'm not sure if we have to find here. See, find is not returning -1. Find is always returning account number. So this is why we don't have to do this here. We always do this. And because if I call find, I will return, it will return index, not -1. It will return itself or it will return parents. Like this. Okay, if I extend, we're adding emails for this found index, right? And then this is the same thing. So see what it's not gonna be -1. Right? We can say if fi not equal I, like this, right? Okay, looking good. Oh, because we are here we are pending, but we have to extend. You know what? I don't have to do this here fine, I think. Because, Hmm. Or should I? Okay, let's try it. It's still just one. Yeah, this is what I think. So I can say if parent I not equal minus one. So will be uh, we will be adding only true roots, right? So if we print here, print our parents table, we are not printing 0, but we are printing 1 and 2 and 3, but we are merging 0 into 1. Yeah, I think it should be. Yeah, and test cases are working suddenly. Um, what if I add not find here and add if fi not equal I, then only then extend it. Yeah, submit. Yay, 12%. Probably because of printing, no? 12%. Okay, you'll find it. See it. Yeah, could it be because we are updating on every time store every time? We don't have to. I feel like this is redundant. Let's try to do it this way, like else. Even worse. Okay. Yeah. So yeah, that's it. We got our union find thing, and yeah, it's um, it's very it fits this task because we need like star map structure, and if we have like continuous structure, we have to find the leaf. So we have to use DFS. We go all the way till the end, and then we start merging from this way. But if because we have a union, find we have like centralized thing, and it's called like in union find it's called like compression or like collapsing search thing when we have when we shortening um, here we're shortening on union um, paths to have just one representative for each set, and yeah, Yeah, that's it. Thank you for watching. Bye.